tank has a height that is always 3 times its radius. Okay, I'm going to draw pictures. I like pictures. So I have this number 3 there. Whenever there's a number, you got to define it. So here's my radius right here. And we're going to just say that's r. The height is 3 times r. If water is leaving the tank at a rate, a rate, 50 is a rate, it's important to know, of 50 cubic feet per minute. Okay, so 50 cubic feet, so feet to the third per minute. Now it's per minute. Okay, so that means 50 is going to be, it's going to be like a dV over dt or something. It's leaving at that rate. So that's a volume, yeah. So I'm going to say dV dt, and I'm going to say V is the volume of the, oh, it's a conical tank. That's a, I drew that wrong. Hold on one sec. Let me fix that. Okay, it's conical, so it means we go like this. And then speech. Okay, there's our radius. And then we have a height that is 3 times radius. Okay, all right, so where was I? So the volume, the V, equals the volume of the cone. So I'm going to say this is a negative 50 because it's the rate that the volume is decreasing. So in our problem, the 50 must be negative. Okay. How fast is the water level falling? Water levels. The water level is going to be your height, right? So I'm going to say that's h. And it says how fast is it falling? So it wants to know what dH dt is, because dH dt would be the speed at which the height is falling. And we should also get a negative number for that too. Now, since well, let me just finish reading. How fast is the water level falling in feet per minute when the water is 3 feet high? So h is currently 3, and your volume of the cone is there. Okay. All right, so look, we got decimal answers. Yes, that means most of the time that we are going to be using a graphing calculator. All right, so the volume is equal to 1/3 times pi r squared times h. Now we know that h is 3r, so let's rewrite that. Let's go 1/3 pi r squared times 3r. Let's simplify this a little bit. So 3 times 1/3, these would go away, and then we would have r raised to the third. So it's just pi r to the third. Oh, that's kind of rad. All right, now I don't have to do product rule or anything like that. So let's take the derivative of this with respect to time. That way we can get our dV dt. So we get dV dt equals 3 pi r to the second power times dr dt. Okay, there you go. And what we want to know dH dt, but we don't have a dH dt in this guy. But the dr dt is related to dH dt. Oh, okay, I can see where this kind of gets a little tricky. So if we wanted a dH dt, we could say this. Let's see, how is the radius related to the height? Let's see. We know that, let's see, r, whoa, my brain's like going crazy here. 3r equals the height. So we can take the derivative of each of those with respect to time. So we get 3 dr dt equals dH dt. Okay, there you go. That's how we're going to find it. So if we know what dr dt is, we can find what dH dt is. And because we know dV dt is negative 50, 3 pi, we know that r is currently, oh no, we don't know what r is, but we're going to need to. What is r? So if h is 3, that means, let's see, if I plug in 3 right here, yeah, that means r is going to be 1. So we can plug in 1 right here. That's for the r, so 1 squared, and then dr dt. Sweet. We're left with dr dt. We can totally solve this. So I start going here. No one cares about you, 1 squared. I divide both sides by 3 pi, so I get negative 50 divided by 3 pi equals dr dt. And then I want to know what dH dt is. So it looks like I just have to multiply dr dt by 3. So those go away, and I get dh dt. And look, it's a negative number. And see, it says it's falling. The water level is falling, so it should be a negative number. But it looks like all the answers are given as a positive number, which is okay because it says how fast is it falling. So, anyways, so we have negative 50 divided by pi. We're going to need a calculator for that. Negative 50, oops. Negative 50 divided by pi. That gives me negative 15.915. So our answer is going to be right here. And it already tells us in feet per minute, so I guess we don't have to label it. Plus multiple choice.